Okay, here we are on page 7. On page 7, this is similar to the last problem we did on page 6, where we're going to do a highly challenging problem where after you do the binomial expansion, they ask you to multiply it times another binomial, which is different. Now, notice that when they ask you to do this, the binomial expansion that they ask you to do is not particularly difficult. If they just asked you to do this binomial expansion and expand it completely, it wouldn't be a big deal, right? The only thing that makes it hard is they're asking you to multiply by binomial afterwards, and then they ask for one specific term. So they're saying basically you don't have to do, the complete expansion, just expand one term. Okay, so what we're going to do again is a cross between, avoiding algebra and being smart about it. Okay, you could do this completely with algebra, but I think the complexity and the chance for error is too high for most students. Okay. All right, so first we're going to take 3x plus 1 to the 9th and expand it a little bit, okay? Not completely, but just enough to see which parts are important. And then afterwards, we're going to do loudest multiplication times 2 minus x. Notice when I did 2 minus x, I put the higher degree negative x on top, and I put the plus 2 on the bottom, just so that I have a chance to maybe do an easy combination of like terms, okay? All right, so let's do the expansion of this. And remember, we're going to try to avoid doing a lot of extra work. So first I'm just going to do, the n value down to 0. This wide paper is useful, okay? And then we make this into the Pascal's triangle coefficients by doing 9 chooses 9, 9 chooses 8, 9 chooses 7. I won't do all these because maybe we'll figure out we don't need them anyway. Okay, and then we're gonna do the a term, which is 3x. So we do 3x to the 9th, 3x to the 8th, 3x to the 7th. Actually, I'm making a mistake here because I don't really need to do the 3 yet, right? I'm just gonna do x for now. X to the 6th, x to the 5th. I'm not doing the 3 because I'm not going to fully develop every single term. Okay, so now let's take a look at what we wanted. We wanted the coefficient x to the 6th term, but that's after we multiply it times 2 minus x, right? Now, we know that some of these powers are too big, right? This is already x to the 9th. If we multiply it by a constant and an x term, it's going to be like x to the 10th, x to the 9th, right? So we know that this is too big, so ignore this one. X to the 8th. X to the 8th, that's also way too big already. X to the 7th, already too big. X to the 6th. Okay, this one has some chance, right? This one has some chance. X to the 5th. This one has some chance because if you multiply x to the 5th times x, then it would be x to the 6th, right? X to the 4th, actually it's too small, right? X to the 4th times x would only be x to the 5th. X to the 4th times 2, it would be too small also. So, if we think about it a little bit, we only are going to use these two terms, and the other terms are too big or too small, okay? So let's fully develop these two terms now. So it would be 9 chooses 6, 3x to the 6th, and 9 chooses 5, 3x to the 5th. So let's see, 9 chooses 6. What is 9 chooses 6? Nine chooses 6. It is 84. And what is 9 chooses 5? It is 126. Okay, so let me write those down. So this would be 84. And this would be 126. So 84, 3 to the 6th, x to the 6th, and 126, 3 to the 5th, x to the 5th. So let's see, what is 3 to the 6th and 3 to the 5th? 3 to the 5th is 243. 3 to the 6th is 729. So let's do 729 times 84. That would be 61236. 6, 1, 2, 3, 6, x to the 6. And then this one here would be 3 to the 5th, which is 243. 243 times 126, which is 3618. 3618 x to the 5th. Okay, now we only have a couple to check out. Okay, so we can make a little bit more space for us. All right. So the higher term would be 61236 x to the 6th, and the slightly lower order term would be 3618 x to the 5th. And then, so if we multiply this times negative x, it would give us negative 1, 61236 x to the 7th. And if we multiply this times this, it would be something terrible. So let's... 122,472. 122,472 x to the 6th. And then what about this times this? It would be negative 3618 x to the 6th, right? Yes. And then if I multiply this times this, we're looking for x to the 6th. So this is going to be an x to the 5th term, so we know we don't need it, right? This would be 2 times that, x to the 5th, so unnecessary. So we have two contributions. We have these two contributions. These combine together to make the x to the 6th term. So we do 122,472 minus 3618. There's 3618. 91,854. So our answer is 91,854 x to the 6th, positive, right? I added those two like terms together, and I'm done. Okay, problem 8. Consider the expression parentheses x squared y minus 2y squared, close parentheses, to the 6th, a binomial expansion with x's and y variables in it. Find the term in which x and y are raised to the same power. Okay, so first we're going to do this with the non-algebra method. So we're going to go to our template and we're going to expand this, okay? So the a value is x squared y, right? And the b value is negative 2y squared, right? And the n value is 6. So let's expand this. We're not going to do, really detailed, because the first thing we're doing is we're just trying to figure out which of these terms is actually the term that we're interested in, right? One of these terms has x squared, x and y to the same power. This is to the 3, this is to the 4, to the 5, okay? That's the Pascal's triangle coefficient. We didn't even go out and find the Pascal triangle coefficient, but we know it's 1, 6, 15, 20, right? Now let's put the a values in, and we're only going to pay attention to the variables. And in the a value case, they're both variables, so we'll go ahead and write them both down, x squared y in each one of the circles, which represent parentheses. And then we'll put exponents. So we'll start with 6 and count down from there. Okay, we didn't go all the way to the end. There's one more term. And now we're going to put negative 2y squared in the squares, except we don't need the negative 2y yet, because the negative 2 yet, because the negative 2 doesn't contribute to the variable part, and we're just trying to figure out when does the x and the y variables have the same exponent. So we're just going to put y squared, y squared, y squared, y squared, y squared, and y squared. And then we're going to put the exponents for the y squared. We start with 0 and we count our way up. Okay, it goes all the way to 6. Now what we're going to do is we're going to ignore the Pascal's triangle coefficient. We're just going to focus on this variable part, and we're going to figure out which one of these terms has the same exponent for x and y. And this is not completely easy because look, there's a y contribution from the circle and there's a y contribution from the square. So we need to like kind of simplify it enough so that we combine these two. So first, x squared to the 6 is x to the 12th. Y to the 6, y to the 6th, and y1 to the 0 is just 1. So we don't have any contribution for this one. For that one, are 12 and 6 the same exponent? No, so it must not be this one. X squared to the 5th is x to the 10th. Y to the 5th, and y squared to the 1st is y squared. So this would be x to the 10th, y to the 7th, so it's not this one either. What about this one? X squared to the 4th, x to the 8th, y to the 4th, and y squared squared, which is y to the 4th. Oh, this looks promising. X to the 8th, and if we add together the 4's, it would be y to the 8th. So it's this one here. It's this one. So the Pascal's triangle coefficient is 6 chooses 2. We have it there. Then x squared y is to the 4th power. And then now we're going to put the full b value in here. So it's going to be negative 2y squared to the squared power. And then we're going to expand this. 6 chooses 2. Remember, row 6 of Pascal's triangle is 1, 6, 15, 20, so it's 15. If you want to, you could go into the calculator and do 6 chooses 2, and it'll give you 15, okay? So that's 15. X squared y is x squared to the 4th, which is x to the 8th. Y to the 4th, this part we already did. Negative 2 squared is positive 4, right? Negative 2 times negative 2 is positive 4. And y squared squared is y to the 4th. So it is 4 times 15, which is 60, x to the 8th, and y to the 8th, because we combine the y to the 4th, y to the 4th. So that becomes y to the 8th. And here's our term, 60, x to the 8th, y to the 8th. That's what we were looking for. Found it without doing any algebra. Okay, so now we're doing 9a. This is a highly unusual problem. As long as you don't panic and you just use what you know, there's no reason why you can't get some or all the points on it. The third term of 1 plus x to the n is 36x squared. Find the fourth term. You might say, oh my god, look at this. I don't know what the n value is. This is the first time this ever happened. Well, sometimes it's going to happen. Okay. All right, so I'm going to copy the problem down here. So they're saying 1 plus x to the nth expands, and you're going to have the first term, you don't know what it is. You're going to have the second term, you don't know what it is. And you're going to have the third term, which is 36x squared, and they want to know the fourth term. Well, to figure out the fourth term, you have to figure out what n is. And so how do you figure out what n is? Well, we know something about what this looks like, right? Let's do our general term expansion or our expansion. Don't get scared about that I said general term. You don't have to know a general term. Just do your Pascal's triangle coefficient. Of course, you can't actually write your Pascal's triangle terms because we don't know what n is, right? Okay, and then, oh, look at that. That's nice. The a value is 1, so it doesn't contribute anything to these terms, so we can just forget it, right? The x value is the b term, and it starts with an exponent of 0. And so on, right? Now, what is n chooses 0? You're like, n chooses 0? I can't do that on the calculator. There's an n in it. Okay, remember, anything chooses 0 is 1, right? The first number in Pascal's triangle is always 1 in any row. So this is 1, and this is 1. So it's just 1. Okay. What about n chooses 1? Oh my god, I can't do n chooses 1 on the calculator because, the n. Remember, the second number in Pascal's triangle is always the n value, right? So it's n times x. Okay, so the second term is n times x. The third term, okay, we do not know what n chooses 2 is, but we could write out the formula, right? What's the formula? It looks something like this. Okay, copy that out of the formula booklet, times x squared, okay? And now we can set that equal to 36x squared. And then we can see that, oh, actually the 36 is the Pascal's triangle coefficient. 36 is the Pascal's triangle coefficient. So that means that all we need to do is figure out what n value is going to give me 36 for this thing here, right? And if it's easier, we could just say, okay, n chooses 2 equals 36. When does n chooses 2 equal to 36? I'm going to give you a couple ways to do it, okay? But, you know, I'm going to start out with brute force because, you know, it's not that, you know, you have a calculator. Every single calculation only takes you 5 seconds. So you could do it, you know, some pretty low technology ways, and you would still get the answer. So let's see. We'll go to math, go to probability, go to n chooses r, okay? And let's start with a pretty big number. We'll do 5 chooses 2. Let's 5 chooses 2. No, 10, it's not big enough. Let's jump up to like 7. 7 chooses 2. Still too small. Okay, what about 8 chooses 2? Looks like we're getting closer though. Nope, too small. What about 9 chooses 2? And you're thinking, really? This is the way we're supposed to do it? Well, I can show you another way, but 36, 9 chooses 2, n equals 9. I'm done, right? So n equals 9. So that solves that mystery. So now that I know that n equals 9, it's really easy for me to figure out what the third term here is, right? Because the third term is just equal to n chooses 3, x cubed, right? So what's n chooses 3 in this case? Is 9 chooses 3. 9 chooses 3 is 84. Okay. So the answer is 84. Another way you could do this is you could put a bunch of numbers here. 3, 4 in stat edit. Now you don't know how to use stat edit that much yet, but you will by the time you get to the IB exam. So you could put a whole bunch of numbers here. Oops. Okay, and then you could go up here and you could do them all at the same time. You go up to L2, you put the highlighter in L2, you do math, probability, n chooses r, and then you put L1 in for that, and then you put 2 there. Ta-da! Oh look, it's 36. Okay, so that's a high-tech way of doing it, but it didn't really take any less time than just doing it the hard way, right? That's it.